Next riddle. If a post is 6 yards longer than half of its own length, how long is the post? Alright, so pause the video if you don't want to hear it. The answer is not 9 yards. It's 12 yards. So the post is 12 yards long, and 12 yards is 6 yards plus half of 12. Half of 12 is 6. 6 and 6 is 12. Alright, you don't have to like it. Maybe you got it, but you probably guessed 9. That's my bet. So anyway, back to polar equations, polar coordinates. One of the most important things that you can do is in polar graphing is to be able to convert, should be back here, to be able to convert from polar to rectangular, or from rectangular coordinates to polar coordinates, or you have an equation in polar, you want to convert that to rectangular, and vice versa. So the equations that we can use to relate the polar with the rectangular come from the relationship between the polar axis, and let me get this straightened out here. And okay, so here we go. So if we take the pole and put it right there at the origin, there's our x-axis and there's our y-axis, and we draw a right triangle here in the first quadrant. Theta is the angle between the x-axis and the hypotenuse, and then we have x and y, and if we could if we put a point right here at the vertex, the other vertex here of the right triangle, it has coordinates x and y, because you go over x and up y, or you could also say that it has coordinates r theta. Theta here is the angle, and remember the first thing you do is find the theta, and then you go r units towards theta, and we have the coordinates r theta. So r theta is the same as xy. Now r is not the same as x, theta is not the same as y. We'll get to that. The relationships that we can use to relate the xy and r theta are based on the Pythagorean theorem. X squared plus y squared equals, so here's one of them, x squared plus y squared equals the hypotenuse squared. We can also use SOHCAHTOA, which I did the first couple of them down here, but we usually want to write x equals. So if we multiply both of these equations by r, we see that x is equal to r times the cosine of theta, and y is equal to r times the sine of theta. And again, these two equations come from SOHCAHTOA. The sine of an angle equals the opposite over the hypotenuse, y over r, and the cosine of the angle is equal to the adjacent leg of the right triangle divided by the hypotenuse of that right triangle. In this case, it's r. Okay, and the last relationship between the rectangular and polar is using the tangent of theta here is equal to the opposite leg of the right triangle, which is y, divided by the adjacent leg of the right triangle, which is x. You can see on one side of the equal sign in each one of these is x, y, or combination, and on the other side is an r and a theta, or a combination of the r and theta. Okay, so this right here, guys, is your bread and butter right there. You need to make sure you memorize those. And actually, you don't necessarily have to memorize them if you understand where they came from. Just be able to draw this right triangle, and you'll have the relationships between the x, y, r, and theta. Okay, so let's take a look at some of the problems that you guys will have to do. Problem number one, we're going to take coordinates in x, y and convert them to r theta. Okay, so we have, let's cheat a little bit. Let's just make sure, because remember, r theta, there's an infinite number of r thetas that can represent one point, but only one set of xy coordinates that can represent one point. So in xy, we have only one pair of coordinates, and that means just one point. So 3 over 3 and up, radical 3 is somewhere right over there. But we know we're in the first quadrant. Okay, so this is your x, this is your y, and we could do x squared plus y squared is equal to r squared. We could do that, and maybe we will in a minute. But first thing I want to do is find theta. Tangent of theta is equal to y over x. Okay, so the y is radical 3, and the x is 3. Well, you should know how to solve this equation. You should know from this that theta is either pi over 6 or 7 pi over 6. Okay, and here we're in the first quadrant, so let's just go ahead and go with the pi over 6. Alright, so if we draw a radius of pi over 6, now the question is how far over are we? Okay, well how far towards that? Well, don't say 3 or radical 3 because it's not. 3 is here and then the circle would go inside of that. So we do need the x squared plus y squared equals r squared. So 3 squared plus radical 3 squared equals r squared. 9 plus 3 is 12. R squared is 12. And so r equals square root of 12 would be 2 radical 3. So therefore, r theta would be, r is 2 radical 3. 2 radical 3 units towards pi over 6. And pi over 6 radians. Okay, and so that is our r theta for that particular point. Okay, we do one more, and then I'll give you guys a chance to try. So negative 2 comma 2 radical 3. So we've got negative 2 here, 2 radical 3 somewhere up here, and we've got a point in the second quadrant. So that's going to help us determine which theta we're going to use. Okay, let's do this again. Let's find our theta. Tangent of theta equals the y over the x. And this is, the 2's cancel, so we get negative radical 3. And so what's theta? Alright, so theta is, got to have a 3 in the denominator, so we have 2 pi over 3. That's our theta. So hopefully you know your unit circle. Still we need that unit circle. So then we need our r. We need our r. Negative 2 squared, so x squared plus y squared equals r squared. So negative 2 squared is 4. 4 plus 4 times 3 is 12 equals r squared, so r is 4. Okay, so our r theta equals 4 comma 2 pi over 3. And there we go. 4 comma 2 pi over 3 is our r and theta. Okay, so what I'm going to do here is I'm going to go over to this side and do the r theta to xy. And here again is our relationships between the xy and r theta. But let's go ahead and do this. So r theta equals x and y. So x, remember, is r cosine theta. So x equals r times the cosine of pi over 4. It's actually easier to go from polar to rectangular. What's the cosine of pi over 4? Well, that's just radical 2 over 2. Okay? And the y equals r sine theta. So r, which is 5, times the sine of pi over 4. And again, we get 5 radical 2 over 2. So 5 comma pi over 4 equals the x, which is 5 radical 2 over 2, comma the y, which is also 5 radical 2 over 2. And there's our answer. Okay, so we're converting from r theta to x, y. These two pairs of coordinates represent the same exact point, and again, it's one of the things you've got to be able to do in polar graphing and polar coordinates, be able to convert from one to the other. Alright, so if you want to try this one on your own, fine. I've got a couple other ones down here you can try on your own. Maybe just watch one more time, and or you can try it on your own. X equal, we're converting r theta to xy. X equals r times the cosine of pi over 6. And we know that the cosine of pi over 6 is radical 3 over 2. And so the x coordinate of this point is radical 3. Y equals r times the sine of theta. And the sine of pi over 6 is 1/2. So we have 2 times 1/2, which is equal to 1. And so 2 comma pi over 6 is equal to xy radical 3 comma 1. These are coming out pretty nicely. Alright, so your job then, and this is our second of 3 parts, your job is to do these 4 problems, and I will leave these here for you, and in the next video I will have the solutions to those, and so you can just stop this video and then watch the next one.